which is NetApp's dynamic storage orchestrator, which is really well adopted in the industry today. One of the first external storage, dynamic storage orchestrator that was created. So a lot of good stuff has been done by Garrett and NetApp, and all the hard questions on Astra, like if you want to know internals, they go to Garrett. So with that, let's start off. You have moved your Kubernetes apps to you have moved your apps to Kubernetes. Either you refactored them, or you created new apps, or you just lifted and shifted, because those are the paradigms we see with our customers. They're running, they're humming, and they're stateful. So they use persistent storage of some sort or some kind. What do you do though if you accidentally corrupt your cloud native database on Kubernetes? It's not that straightforward. How do you get back your data that is not corrupted? What do you do if your public cloud AZ or region hosting your Kubernetes cluster is having an outage? It's not obvious all the time. And how do you quickly move your applications to a separate cluster to test with more traffic? With Kubernetes, you can have lots and lots of clusters. I just heard the customer for hours yesterday who has 700 clusters running in production. How do you do blue-green testing? How do you do, how do you move things around very quickly? You can do that today with 25 steps, but it's not easy. Now, you guys already know this, that Kubernetes was stateless. Enterprises drove stateful applications to Kubernetes. This is all old news, yesterday's news. We're not talking about that today. And for the most part, persistent storage for K8s, as Nigel indicated towards the beginning of this session, is a solved problem, right? The CSI interface is stable. There's plenty. There are 92 implementations of CSI drivers out there. They're doing the job, right? So consuming persistent storage for Kubernetes is it's not something that is a problem that it was 3-4 years ago. Okay, when I started on this Kubernetes journey myself at Red Hat, but the next wave of stateful applications on Kubernetes actually need more than just persistent storage, and these are business critical applications. They need to be highly available. They need to be protected from disaster, and they have mobility needs. And I'm quoting a survey here from CNCF, which is publicly available, where 55% of the respondents of the CNCF survey in 2020 said that they are using stateful applications in containers in production, and a whole bunch of other people contemplating doing that. So people are moving or working, trying to move their stateful applications to Kubernetes because they like the platform. And for the most part, Kubernetes, the move to Kubernetes is also developer-led. Developers love Kubernetes, and they need state in their application to work well. So NetApp's Trident has solved the persistence problem for stateful applications from the NetApp point of view. So this was originally released in 2016. It's a CSI compliant persistent storage provider, but saying that it's CSI compliant is not doing justice, because Trident does a lot more than what your typical CSI compliant driver does. It basically gives you, very advanced features, exposes very advanced features from NetApp storage arrays like adaptive QoS that you can take advantage of in your Kubernetes applications if you are using Trident. So it's more than that. But again, Trident has been the forerunner here, establishing NetApp's credibility in this space, and is doing a great job today. However, what we have found out, and mostly through our Trident customer-based perspective, that stateful applications need more than just persistent storage. Persistent storage is a great start, but that's not everything. That's not the only thing people need when they're running their business critical apps on Kubernetes. Even in the cloud native world, data cannot be lost or corrupted. That's a given. Business continuity is more important than ever, and in cloud native world, it doesn't go away, right? So you cannot have an outage for hours and everything is not fine. the other thing that there are a couple of other things that Kubernetes has added to this equation, which you may not find, or even if you find, it's not that common in the traditional world, is application portability and mobility is more important. Thanks to Kubernetes, you can run and scale your clusters easily. I mean, fundamentally, at its core, I think about Kubernetes as a cluster communication technology. That is, you can launch a bunch of clusters, run your apps, take them down, extend them, and Kubernetes makes it really easy. Consequence is you end up, creating lots of clusters, and sometimes when you have that many clusters, you need to move the apps that are running on them from one to another, and it's not very easy with Kubernetes today. The other thing that Kubernetes has also brought into the mix because of this, making it really easy to run clusters, is the application data that's created inside a Kubernetes cluster by apps is sometimes more valuable than the clusters themselves, because the clusters come and go. You create them, you delete them, but the data that was created by the apps in those clusters, they need to be managed beyond the life cycle of the cluster itself. And enterprises need a solution for that, especially in the FSI space, because data is, it needs to be governed and retained and all that. So there's a lots of data management needs that have cropped up. And although these needs are there, Kubernetes data management is still not very easy. So even if you look at although persistent storage is a solved problem, provisioning it and protecting application data is still complicated. Moving your applications from one Kubernetes cluster to another is tedious and error prone. There's not enough Kubernetes tooling for app aware, disaster and data recovery or backups. There's CSI standards for taking a volume snapshot and cloning from a volume, etc. But there's nothing that kind of encompasses the entire Kubernetes app, and I'll come to that. There's more on that later. And the community is doing a great job, but there's still a lack of open community standards and APIs in this area, and the community is kind of trying to fill in as fast as it can, but customers need these things today. So what are customers doing? They are actually working around. In many cases, they are only running stateless applications on Kubernetes. And so it's a powerful platform, but they're not able to take advantage of it. In other cases, they are running the stateful portions of an app in K8s and the stateless portions of an app in K8s, and the stateful portions outside K8s so they'll run a VM. They'll run a database in a VM outside the Kubernetes cluster, and try to manage and maintain state and store state and access state from that, which works, And in other cases, what we have seen is customers are simply using some fully managed database as a service in a cloud or object storage, actually, outside the Kubernetes clusters for maintaining state. Now, all these approaches, they work, but if you have a multi-hybrid cloud strategy, they sometimes run counter and can lead to a lock-in, which might be difficult for you to resolve once you have moved a whole bunch of applications and architected them that way. So we are introducing Astra. Literally, we're launching it today, we are, it's been in service for a little while, but GA, we're launching it today to kind of take care of a lot of these issues. Astra is actually the world's first fully managed data management service, built for Kubernetes, and I'll go into the fully managed aspects of Astra a little bit later, and you'll be also able to see that live when Garrett gives you the demo. But it's really truly the first of its kind. The use cases that Astra is going to cater to and is catering to right now are things that we talked about. It's data protection, data disaster recovery, migration and portability, audit, retention, governance that enterprises need to run their business critical apps on Kubernetes. And how we're doing it with Astra is what is the big clincher, is that we are using NetApp's proven storage and data management portfolio both in cloud and on premises to make it happen. So it's really the best of NetApp, coming to Kubernetes for solving its data management issues. So with that, let's focus on what's unique. So Astra today operates on the application as a whole. What I mean by that is Kubernetes apps can have lots of things. They can have pods, deployments, stateful sets, daemon sets, config maps, secrets. They all make up an app. A standard Kubernetes app may have like 7, 8 resources, even a small app. And so if we focus just on the storage or the infrastructure aspect of Kubernetes protection, we're going to miss out on how customers actually want to look at Kubernetes, which is from an app perspective. So when we designed Astra, we made sure that this was the primary focus. We are not, we're looking at app-aware data management for all of our workflows and for all of our use cases. So it's not, okay, let's take a snapshot of a volume, that's attached to a pod and then clone it from it and move it, right? Or back it up that way. It's actually, identifying your application and operating on the entire set of resources that an application consists of as a whole. So we focus on the application as one unit and not just individual components. This is very important. And all of this, and the way we build for it, the way we construct it, and the way we go to market with it is all around this application awareness. We actually are, billing for Astras with managed apps, like how many apps you're managing per minute, as opposed to, amount of storage managed. That's not how we're doing it. And so that reflects in the design philosophy. From the design philosophy, go to market, we are app-centric. So this is the classic layer cake, to understand where Astra fits in. We're basically asking our customers, bring your app, bring your cloud, and bring your Kubernetes distro. And Astra with Trident and NetApp storage portfolio will do the rest. So we are not competing with any Kubernetes distro out there. We'll work with everybody, whether it's on-prem or in the public cloud, self-managed or fully managed. So this is very important. Just want to make sure that Astra will be working with the Kubernetes that you want to use, not mandating that you must use this Kubernetes or that Kubernetes. You choose your Kubernetes, you choose your cloud, and you choose your app. We do the rest. So what does Astra provide? So basically, if you look at it, and there's a long, we're starting with this, but this is just the beginning, So application-aware data management for protecting data with snapshots. Enable disaster or data recovery with remote backups. You can migrate apps with instant active clones. You can audit all the operations that were done to your app with activity logs. So, per user. So you can see, user 1 took a snapshot at this time, backed it up that time, cloned this application from this cluster to that cluster at that time. So all of that is available, which is very valuable sometimes for a lot of customers because of all the data and the apps that are getting created in these clusters, and they want to keep a trail of what's going on. And secondly, which I want to really kind of emphasize on is we really designed Astra with application and data portability in mind. Not just that you can use Astra to move your application from one cluster to another cluster, but across regions within a public cloud, across on-prem and public clouds, across clouds with just a few clicks. And that's the clincher. We have made Astra extremely simple to use. You can do all of this today, but you need 45 steps. And there's so many use cases our customers talk about today that where this is absolutely critical. So customers often move their app and data from one region to another region in the cloud because of data residency requirements. For hybrid use cases, we see customers who want to move their applications from on-prem to the cloud because they have a lot of data on-prem, but they don't have compute to process the data. So they move it to the cloud because in cloud, you can have on-demand compute capacity to crunch that data. There are other requirements like follow the sun, like you have application teams across the world where, they need to work on an app along with the data at different times of the day. So there's so many use cases for this, and we are building Astra to make sure that we can cater to all of these scenarios, and that's the most powerful, and not just like, okay, you can do this with a bunch of command lines, and a bunch of configuration tools, but just 2 clicks, and you'll see the power of it when we do the demo. But this is something that's very unique. So what is Astra? In what form does it exist today? So today, Astra is a fully managed service, which is operated by NetApp, providing a consistent experience across cloud. So it's an always on and updated service with latest functionality. You have to download no software. You don't have to install, patch, upgrade, manage, or license, nothing. And this is the console you will see. If you are using Astra to manage GKE clusters in Google, or AKS clusters in Azure, or on-prem clusters, eventually, AWS clusters. So there's nothing like, for each of these cloud, everything is different. That's not. Once you add a cluster to Astra, it looks exactly the same. And some of them could be in Google, some of them could be Azure, but it's exactly the same. And the interface that's exposed to you to take a backup of an application doesn't change. So that's like really powerful, for because a lot of our customers have, multi-cloud, or I'll say hybrid cloud environments, and the last thing they want is to learn and relearn, tool sets and that are specific to a different Kubernetes system. Even though there are standards around it, there is stuff that's slightly different. And we kind of, provide you a single pane of glass for doing all of that without needing to worry. So it's very powerful, and it's UX and API. So it's both. So you can use the UX, and then the API is coming in a month, and you'll be able to use completely programmatically do your disaster recovery workflow. So it's that way very powerful. So the vision for Astra is to be a true multi-hybrid cloud data management solution for Kubernetes. We are starting on the left. So we have support for applications running on Google Kubernetes engine, running on Cloud Volume Service for GCP. CVS for GCP is a fully managed NetApp storage service. So, and we're providing that. We'll add support for Azure soon, followed by on-prem and AWS. So that's when this happens, and all of this is going to unfold literally in the next year, within the next year or so. You're going to see a true multi-hybrid cloud data management platform that you can use across or within, and even if you do not have a multi-cloud use case, many customers don't, you can still use it across hybrid cloud or within a cloud, and that will just, work, and it's totally up to you how you want to use it. So we'll provide all the features that you might need, and then you can use a subset.
In the case of on-premise installation, I was wondering, where is Astra software installed? Is it on cloud? Is it on premises? Is it kind of cover or umbrella?
So that's a very good question. So initially, we are going to have an on-prem variant for Astra that will look exactly like the cloud variant, but it will be self-managed on-prem. But for hybrid use cases, when you have clusters both in the cloud and on-prem, we're going to have that managed from the cloud. So the reason we are doing this both is we have 2 classes of customers. There are some customers who absolutely do not want to use a cloud-connected tool for managing their on-prem, while there are others who would love to use a cloud-connected tool because they have hybrid storage use cases. So we'll do both.
Great, thank you.
So how does Astra work? So Astra today, literally, these are the 3 things. It works in 3 simple and easy steps. The first thing that you do is you just register your Kubernetes clusters with Astra. That's the first thing you have to tell Astra that, hey, I want you to manage or watch these clusters. Once you do that, Astra will automatically discover your applications in the Kubernetes clusters. And after that, and you have the option to choose once the apps are discovered. You have to choose whether you want them Astra managed or not. Say you have 10 apps, and you only want 3 of those to be managed because the others are stateless or you don't care, they're test applications, whatever. But the 3 are production and you need to take snapshots on a daily basis. You can choose those 3 and add them to Astra and ask Astra to manage them. At that point, what you get is a menu of data management operations that you can choose from. You can set up protection schedules, like snapshot schedule, backup schedules. You can view the activity log of who has been doing what. And at some point, if you do not want to have that application managed, you simply unmanage and we stop managing it for you. So basically, it's real simple. It's like 3 easy steps, and you do all of this without downloading, installing, patching, managing, upgrading any software. It's just add your clusters, and we do the rest for you, including, and which is, I didn't talk about it as much, including provisioning the storage. So all of the storage provisioning is automatically done by Astra. It actually lays down Trident on the cluster. So when you kind of choose, go through a menu of adding a cluster, you also get to choose your storage class. That's already done. And after you have chosen the storage class for your default storage class, you're off you go. And Garrett will have a demo on that, so you'll see that. So Astra in a nutshell, sorry, go ahead.
I just wanted to clarify really quick. One of the common thread that I saw, at least from the storage layer, was the NetApp storage and the cloud volumes across all the different cloud providers. Is it true that the NetApp storage is a strict requirement? And do you have, if so, do you potentially have any plans to add any other cloud native storage components to that in the future?
Yeah, thank you, Adam, for this question. Very good question. We are starting with NetApp storage, and we are picking the ones that are fully managed, at least in the cloud. But we definitely see an opportunity to add cloud native storage to Astra, because if you look at the functionality that Astra provides today, it's actually storage layer agnostic. Like, you could have any storage there, and we should be able to manage it for you. We should be able to take backups. We should be able to do snapshots. We will be able to clone. We'll be able to restore. We'll be able to do more data governance irrespective. So we're definitely looking into adding cloud native, storage offerings from the cloud providers. But it's still kind of a roadmap, whiteboard item we're discussing. So I cannot give you the exact plans today, but it's on our, it's something that we are actively looking at.
I have a follow-up question to that.
Sure.
As part of the onboarding process in our simple and easy 3 steps, if I don't already have NetApp storage backing my cluster, will this process migrate my existing applications to that NetApp backed storage, or is that something I have to do?
So at the currently, you will have to do it, but we are looking at tools, migration tooling that makes it easy to move. Say you have your apps running today on some other storage. We are looking at how to make it easy for you so that you don't have to. Right today, the onboarding process doesn't include that step, because we think that's something that has to be you have to be very conscious when you make that decision. But we'll try to make it as easy as we can. And I think it's container-based storage migration is probably much easier than VM-based storage migration because of the amount of data involved and how the volumes are carved out, etc. So to answer your question, it's not included in the steps, but we'll provide tooling to make that happen so that you can basically take advantage of Astra for your brownfield applications.
Okay, great. And that second step where it discovers my applications, that feels a little hand wavy at the moment. So are you going to get into exactly how it's doing that discovery and what components it discovers automatically?
Yeah, so I think that's something we can show that you in the demo, like how it is doing it, because we have come, we have basically with our combined, we have done a lot of research with customers on how best they, what are the most common ways by which they deploy their applications, and we have chosen the most popular methods so that we can go and discover based on how Now, having said that, we think this will evolve as Kubernetes formalizes what actually is an application, and there's a SIG in Kubernetes working on this called SIG apps. We will adopt it, but right now, we use Helm charts, we use labels, we are adding operators, which are the most popular ways of deploying Kubernetes applications on a cluster. We are going to kind of we're going with those for now because they're kind of a de facto right now. But as the Kubernetes community comes together and defines SIG apps and defines a more formal application posture, we're going to adopt it.
Okay, great. Thank you.
I also have a quick question about storage as well. Sure. Because Astra is making its own decisions, or basically depending on the cloud, I think there are different kinds of storage, but NetApp storage being used, and currently it's just that. So there are different performance levels as well within NetApp storage environments. Right. I was just wondering, how is it making those decisions based on whatever storage is using underneath? Or is it that you can choose? So if, for example, Cloud Volumes and Cloud Volumes ONTAP both are available on a certain platform, is there a decision-making process over there which is manual, or is it automatically made? And how performance metrics are sort of calculated as to how to get a certain level of.
So today, when you actually add a cluster, to Astra, you actually have to make that decision, like what is the default storage class, and we will display you the 3 performance tiers for CVS, for example. It's it's standard, premium, and extreme, I think, or ultra, I forget, one of those, and you kind of have to choose. Now that becomes your default, but if you want to deploy apps with a different storage class, you can always do that anyway. So it's something that you choose, during the setup of a cluster today. But we're going to make it so that we believe that as we add, support for cloud native storage, there will be a wider choice of storage classes, and you'll be able to make that decision. Both times. That is when you initially add a cluster, and later on when you're actually adding apps and you do not want to use a default storage class, you'll be able to use a different storage class if you need to. So Astra, in a nutshell, it's a fully managed service, the first one for managing data management, built for Kubernetes data management. We are using proven and industry-leading storage and data management functionality from NetApp. That's like a pretty big thing. 25 years of enterprise deployments, technology coming into this space, and it's a consistent and simple data protection management experience that you'll see just now.
Thank you again for allowing me to come in front of you guys and show us our latest innovation, which is Astra. So I'm going to go ahead and share my screen here. This is Astra. This is the dashboard that you see when you first join a cluster. When you first join Astra and you see this, you'll see this screen and it'll be all zeroed out. Right now we have a couple of managed clusters, no managed application. And like Sayan said, what you're going to do when you first come in here is you're going to basically start adding clusters to Astra so that we can discover your applications and then add that additional layer of capability on top of them, as well as do things like deploy Trident and whatnot. So right now I've got one cluster that's in Northeast 1. This is in Google Cloud. You can see that there's a little Google Cloud logo, and you've got this location up here. And I can already see, for example, some of the applications that are in this cluster. But right now what I'm going to do is add another cluster, because I'm prepping to be able to do an operation with this later. So I've got this Northeast cluster. Now what I'm going to do is I'm going to add another cluster under Google Cloud Platform. I'm going to use this service account. Now it's important, this service account has to have the necessary roles. And if you just hover over this, you can see which ones that we need in order to do our job. Because we're doing a bunch of things behind the scenes that I'll go through in a little bit, and I'll explain what's happening. Because if you just go through the clicks, it's like, oh, wow, it worked. But, there's a lot of automation going on behind the scenes to make that happen. I think it's important to kind of get a feel for what all that is. But we're taking this one credential, and this one credential then eventually it allows us to do everything we need to do from this point forward. We don't ask for kube configs. We don't ask for, please go modify Kubernetes yourself by hand and all these other kinds of things. It's really important for us that you just give us this one key with just the right amount of access, and we can automate the entire experience for you. So the very first thing you're going to do after you give us this credential, and I'm just going to use this save credential that we had from before, is we discover all of the GKE clusters in Google Cloud that we can manage. Now, there are certain eligibility requirements based on the fact that the cloud volume service that we're going to lay down, requires NFS, for example, right? It's an NFS export that we're exposing. And so we need to make sure that the worker nodes in the cluster have the ability to mount things over NFS. And we have other requirements too, like Kubernetes versions and so on and so forth. So I just hover over like one of these, you can kind of see in this particular case, this particular cluster has an older version of COS that doesn't have, which is the container optimized OS that Google supports by default, that did not have an NFS library at the time. We need Ubuntu nodes in this case. COS now has an NFS has the NFS client built in, so we can use COS too. But this is an older cluster, and you can kind of see this fall out here. And I've also got this existing cluster here that's managed. I'm going to manage this new cluster here called Garrett Demo West 2A. So I've got one in the Northeast to one West 2. The next step I'm going to take you through is configuring storage. Now this is basically where you just, okay, we've discovered then the Cloud Volume Service that's available in that location, right? Another eligibility requirement is that the Cloud Volume Service is available there. And in which variant of it is and what service levels are available there, right? So we know that these 3 service levels are available. We're choosing there's a recommendation. You can choose whichever default you want. And we're basically setting a new default and laying down these storage classes inside the cluster and giving you a sense of what this the storage capabilities are for these different storage classes, before you lay it down. Then you just review what you're about to do. So that was a couple of clicks to get to this review step. And what's cool about this is we're kind of explaining everything that we're going to do. Now we're going to capture that service account that was provided at the beginning. If it was a new one, we'd save it. We're using an existing one, so we use that. We're going to find an object store bucket to be able to host backups for this compute cluster, or use an existing one if we have one in an appropriate region already, right? So we automatically have integration with GCS in this case. And by cloud provider, we'll use the native object store and also allow you to add your own buckets with your own S3 compatible provider if you desire something else. The other thing is we're going to configure compute, but that means basically using the credentials we've already been given to create the appropriate service account in that Kubernetes cluster so that we can actively manage it and the applications within it. So we're doing all that by hand. You don't have to give us a config, we just do it. And then we're configuring the storage, which means laying down the Trident operator, laying down the Trident configuration against those storage classes, laying down those storage classes, so on and so forth. One click, and that's what's happening behind the scenes right now. So then it comes in here, and the very next thing you're going to want to do is you're going to want to go look at the applications that are in that cluster or add a new application to that cluster that we can then manage. So I'm going to go into this application view right here. And you can see in this application view, I've got this application called TPS reports that is this app running in Northeast 1 right now. And I just happen to have this, it's just this MediaWiki application I happen to have open right here, just to give you a sense of, this is a real running application. And I'm going to go ahead real quick and just log into it. So put the Cloud Field Day logo on there. All right. So now I'm going to go back to the app, right? And so we've got that. I made that change to the application. And what I'm going to go ahead and do is I'm going to manage this application. This is basically, this is me deciding that I want to manage, I want Astra to provide its capabilities on top of this application. So we bring this in under management, and it falls under here, under managed. And you can already see right away, we have the ability to see that this thing is unprotected because there's no currently any backups, application level backups, and there's no protection policy associated with this. And we'll go through that in a minute. But what I want to do real fast is I want to kick off the cloning process. So while that's happening, I want to describe what it's doing, but it takes a little bit of time because it's moving from one region to another. So I want to just kick this off while we're talking about it. Let's modify these so that you can kind of see it's the same app. So I can choose to actually clone it in the same cluster or clone it in a different cluster. And Astra is smart enough to know that if I'm cloning from in the same cluster or in the same region, I can actually use the storage level cloning capability, if it's available, to give you like basically an instant kind of clone of the application. If I'm moving from one region to another, I need to use some other, like in this case, we're using an object store as an intermediary. We'll be able to add more and more capabilities later to give you more flexibility in how those things are, how that stuff is done. But I want to make sure that everybody realizes that Astra is figuring out what is the intelligent way to do this right now. Like what's the smartest way that we can do this? And so I'm gonna go ahead and do this clone. You can see that we're taking this application that's here and putting it in West 2, and then kicking off that process. Now, what's happening behind the scenes here is interesting. It's actually gathering all of the resources that are associated with that application and saving them away. The Kubernetes resources, all the ones that Sayan was talking about earlier. And I can actually show you that list here. If I dig into TPS reports, you can see we recognize all the images that are associated with that application. We can see that there's a pod running and what its current state is in Kubernetes. And like I was talking about before, the list of resources that we associate with that application. So you can see here, there are config maps, there's deployments, there's PVCs and pods and everything. We captured the right set of resources here to be able to capture the state of the application, its configuration, as well as the volumes that are backing it. The other thing that we're doing is we're recognizing that this is MariaDB behind the scenes, and we know how to freeze MariaDB to get a consistent state on disk. So under the covers that we're also doing that. We basically talk to MariaDB, say, flush your state to disk. We capture a volume level snapshot for the PVC that's backing that MariaDB database. And then we make sure that the whole thing is consistent. And then what we're doing is taking all that data, shuffling it out into an object store that is, in a region that's appropriate for where this cluster is living. And then we're going to that other cluster and unwinding that whole process. So we basically look at, the namespace we were given in the request. We create a new namespace. We create PVCs that match the storage on the source side and the destination side. We suck the data into those new PVCs, and then we layer all of that application configuration on top of all of that, automatically. And we have to do that in a very intelligent way. It's not as simple as like just copying and pasting these configurations that I'm sure you probably understand. You have to actually you have to understand what these different resources do and bring over just the right bits. And in some cases, you have to transform certain bits in order to make certain things happen. So all that intelligence is built in. We don't have to ask you what you would like for any of that. We just automatically take care of it so that it's running on the other side.
So this is app by app, right? Can I select the whole namespace and collect? I guess where I'm going
Yes.
is, can I, where I'm going. Can I capture a whole namespace?
Absolutely.
I don't care about what app's running in that namespace. I just want to clone the whole namespace.
That's right. Yeah. In fact, you absolutely can do that. In fact, if I show system apps here, you'll see a lot more apps, right? Where you can see Cube System, you can see Trident, in fact, and other, I look at the discovery process as more like a hinting mechanism. In fact, you can see this grouping here. So if the group here is just the namespace, then you're getting the whole namespace and any new resources that show up in that namespace at any time. If you're getting one of these, this comes from basically our app intelligence. We can discover that it's a Helm app that has these certain labels on it. And we allow you to refine it to just whatever that Helm application is, for example, or the operator, if you want to. But yes, you absolutely can do it at a pure namespace level as well.
So you also said something that can you actually schedule this to where if I add new apps into that namespace, it'll always capture those new applications that get deployed into that namespace?
Like auto manage kind of a
thing?
Yeah. Yeah, not yet. We've totally talked about that idea. I think it's a really good idea, and I think it's something that we should work on soon, but it's a roadmap item right now. But,
okay, cool.
Yeah, but yeah, that's a great idea. And you of course can schedule, snapshots and backups, and I can show you how that works. So, that provisioning is still going on. So I've got this, app protection status here and the app status. So just so you guys are aware, app status basically means inside of Kubernetes, does Kubernetes think this app is healthy or not? Right. And we just basically roll up all the status for all the resources. And then, and place that here. And if it is unhealthy, well, you can hover over the tooltip and see that there's a tooltip there that will say, what is it that Kubernetes is saying is bad about this app? And you can dig into some of these details without having to actually go to the command line and figure out what's going on. And then you've got this partially protected status. Now, the reason it's partially protected, it was unprotected before, is we're in the process of actually creating a backup now, right? In order to be able to move that application. So we have this backup. And because this backup exists, we now consider it to be partially protected because there is a recent backup. I think, I forget what it is. I think it's like if in the last week by default, if there's a backup there, we can basically consider it to be somewhat protected, and then if you go in here, you can configure a protection policy. So let's say, you want to do, keep the last 4 snapshots at the 30th minute. You want to take every 30 minutes, you want to take, once an hour at the 30th minute, you want to take a snapshot. You want to keep the last 4. It's very simple. You basically do that and the policy will get created. You can see now it's fully protected, right?
Hey, Garrett.
Yes.
I have 2 questions. First, when it's taking that backup, is there any concern about performance penalty? I'm thinking of like when you used to stun VMs to take a snap and you want to do that at night because you were worried. Is there a concern over that being a performance penalty for taking backups of these running pods?
It absolutely can happen. So obviously for, in these cases, we're taking a snapshot of a volume, right? And then what we do to take the backup is we don't do it with the live copy, right? We do it off of that snapshot. So really what's happening under the covers is we are taking a snapshot of the application that's basically instant using the storage capability, then cloning that volume to a new location. And then we actually suck the data off from that clone with separate pods. Right. So they all have their own resources and own resource requirements. Right. So it's more we're depending on Kubernetes to allow us to run the backup operation or not, in addition to what the application requires. It's kind of off to the side a little bit. Does that make sense? Okay.
Yeah, that makes sense. Yep. In terms of the protection policy, can you associate that protection policy with labels or annotations within Kubernetes so you can automatically apply it to new applications when they're created?
This is absolutely just like the last question. This is what we want to be able to do. So we have this idea that's coming soon that has to do with auto managing applications and also having a default protection policy associated with that, right? And so if the application comes under management, there is at least that level of protection automatically for every application that shows up in the cluster that we consider to be an application, right? We of course would hide system things or things we know that are that you probably wouldn't want to protect by default unless you asked us to do it. So I think that's the main way. I don't know of a label way, right now that we're thinking of, but that's an interesting idea. I think we should look at it.
Okay, great. Thank you.
Yeah. Okay, so we've got that cloning happening behind the scenes. I'm just going to poke around a little bit at this to give you a sense of what else is here. So like I showed, we've got the pod status for this application. We've got the data protection stuff here. So you got the list of snapshots and backups associated with that. Now, these are not volume snapshots and backups, right? These are application level snapshots and backups. We can also see the storage that's backing this. And this is pretty cool, right? Like the information you're seeing here actually comes from multiple locations, and it's all jammed together on this one line because so you can see all of it at once, right? We've got Kubernetes level information, we've got Astra level information, and we've got CVS or Cloud Volume Services level information about like usage and whatnot. That's in here. And this is a common request that we got from on the Trident team was give us more information about what's going on with these volumes. How much is being used? Are they online or offline? Give me a bit more status. And we're rolling up more and more of that into here in one central location that is app centric, because I don't think anybody goes through, maybe they do, but I don't know if they want to go through just the full list of volumes alone and says, are these things all online? I don't know what applications they're connected to, but I hope they are. If not, what application is impacted if one is not online, or if the usage is getting high, what do I do? Which application team do I need to talk to? This kind of thing. This allows that conversation to happen, right? Just the visibility alone. And we're also planning on doing a lot more interesting things with this. For example, like automatic volume expansion and other features like that are coming soon. All right, so we've got the application. You can see now, while we were talking, we've got this, TPS reports. this other version of the application running in this separate cluster, which of course it is unprotected because it's a new clone of the application. I'm going to run over real quick and just get the endpoint for it. If Google's going to, we backed it up, we restored it to a new location. This is running in that other cluster right now, and it retained, the state. It got the logo moved over. So that's effectively, the Astra clone demo. We also obviously have an API. You can go in here and see that, get access to the API, generate API tokens like you would expect. Granted, this is all a cloud service. We didn't have to have you install anything, go to the command line for anything. All you had to do was tell us you want to start managing clusters and applications in Google Cloud, and we took care of all of that for you.
How do people get started? How can they try it?
So we have a free trial for Astra that we are offering, which is unlimited in time, free for up to 10 apps. So you can just go to cloud.netapp.com/Astra, and you can just get started. So today we're supporting Google, and in a couple of months we'll be supporting Azure. But it's documented very well. You have a few prerequisites that you have to do in Google Cloud, and then off you go.